All right, welcome everyone. So today things may look a little bit different. So I'm not sharing my document camera like normal. Instead, we have three guest panelists, or hopefully we're going to have four guest panelists. There was another one who we thought might make it, and we'll see what happens. But yeah, I'm excited to welcome all of these recent UCSC grads who took distributed systems this course when they were students at UCSC and have since graduated and are off in the world doing amazing things. So we have Emma Gomish, Pete Wilcox, and Lawrence Lawson. And I'm going to ask each one of them to introduce themselves and talk about themselves for about 60 seconds or so. And then we'll proceed to do a panel. So I have some canned questions that I want to ask all of them. But if you have questions for them, students in the class, or people on Twitch for that matter, you can. So you can ask a question in chat, or you can, if you're in the Zoom meeting, you can ask a question by audio if you want to as well. So with that, let's get started. So let me ask Emma to introduce yourself first, and just tell us, like, for 60 seconds or so, a little bit about who you are and what you do.
Hi, everyone. I'm Emma, and I graduated in last year, 2019. I graduated with a BA in computer science, but I walked in commencement with the game design program. I sort of crashed the program in my senior year. I walked into their capstone year-long class and basically offered my services as a producer for a video game team, and one of the teams took me on, and I've been doing that ever since. So I'm actually still working with the team that I graduated with right now. We formed a company, and we are like actively seeking like publication. And so I've been a producer for a video game development team for about a year and a half now.
And this is the game that you began development of as a student, right?
Yes, yes, it is.
And are you, Emma? Where are you? Are you based in LA?
Yeah, I moved out to LA with a friend of mine that I graduated with because there's a lot of video game development out here. So they work down in Playa Vista, and I work at home.
Cool. All right. And next we have Pete.
Yeah, I'm Pete Wilcox. I also graduated last year with a BS in computer science, and now I'm in the PhD program in computer engineering at Santa Cruz. I'm in the Center for Research in Storage Systems with Heiner Litz, so I'm doing systems work, and mostly I work on storage accelerators and storage networks. Yeah, that's about it for me.
So you moved right from being an undergrad at UCSC to joining the PhD program, right?
That's right, I did. I had a really good relationship with my computer architecture professor, who I suspect a lot of your students also took this class. And there was an opportunity to jump right in and get started on some industry-sponsored research work that he had, and so I took it.
Cool. All right. And last but not least, we have Lawrence.
Hey, my name is Lawrence Lawson. I kind of feel like I'm in an interview right now. So I'm a machine learning infrastructure engineer at a tech startup called Beyond Limits here in Glendale, LA-ish area. I graduated last year with a BS in computer science. When the world is normal, I usually go to tiki bars in Disneyland, and go to work and everything as well. But right now, obviously working from home and doing this, and also trying to figure out how to make it easier for people to sell their turnips on Animal Crossing. So making a REST API to scrape the Turnip Exchange website, which is really fun. But yeah, that's a little about me.
Cool. And what I recall about your, so I believe all of Lawrence and Pete and Emma took distributed systems from Peter Alvaro in fall 2018, and then they were all part of my course staff in the following spring, spring 2019, last spring. And if I recall, I remember Lawrence, you saying that the stuff you did in the class had a direct influence on you getting hired to do the job you're doing now.
Yeah, definitely. So I don't even remember like how or when I applied for the job I have now, because when you're like in your senior year, you're just applying to everything, and it's just like I don't even remember. And then they call me back, and one of the things I recognized is that part of their tech stack was Golang, and when Pete and I were partners in the class for in one of our the choices we made were to like, instead of using Python or a different language or Java, it was like, hey, we don't know Go, let's learn Go, and the rest is history from there. And that really helped because not only like did a lot of like the core concepts of like the class help, but like we really made a real application using the language. So we got a real like we just dived right really deep, and that kind of like showed like a depth and a breadth of the knowledge of like that language and a lot of distributed systems concepts that I think a lot of undergrads don't really have, and that for the places that I interviewed at, they're pretty impressed by.
Yeah, something that I've noticed is that so a lot of undergrads don't take distributed systems at all. It may not be offered at a lot of places. And certainly some of the stuff that we cover in this class, which is the design of this course is Peter's. I mostly stole his course design, especially covering things like consensus protocols and so forth. It's rarely covered at the undergrad level. I certainly didn't learn it when I was in undergrad. So I think that can make you stand out as an applicant. Okay, so some people are starting to post some questions on our course Slack already. And also Emma, a comment for you. Somebody comments that Squish was great. Squish was the game that Emma and their team developed. And so then here's a question for Emma from another student. Does your team have funding for the game?
We got a little bit of funding. We actually were awarded a grant from UCSE when we graduated, and we received another small grant from UCSE while we were in school, and we are trying to make that money last as long as possible. So we have very little in the way of funding. We're all currently, some people are working other jobs, some people are like living at home and just trying to scrape by. We've actually lost a lot of team members because we can't pay our team a salary amount. So we're about down to half the size we were when we graduated because people have been getting jobs in other places that actually pay money.
So what about you? Are you working full-time on the game?
Yes, I work full-time on the game. I was a dedicated producer, which is a video game equivalent of a project manager throughout the school year. And then a couple months after graduating, I transitioned to doing programming as well. So I also work like directly in Unity, and I handle all of the Git repository stuff because Git and Unity don't really like interacting with each other. I do all the builds, I run playtests, I work with publishers, all that sort of stuff.
Interesting. So so I have a couple of questions that are kind of specific to the game, but specific to kind of what you just said. So this interaction between Git and Unity is interesting. So do game devs not typically use version control like Git? Like do tools like Unity have their own built-in versioning, or how does it work? I know nothing about this.
Yeah, Unity does have its own version control that I think is based on Git called Colab, which I've heard is pretty bad. from what I understand, the industry standard is to use Perforce, which is very old version control system and works somewhat differently. It's not the same like underlying architecture as Git at all. But really the only problem between Unity and Git is that Unity generates a lot of YAML files whenever it compiles and whenever it runs. And so those generated files have to be in your version control because they have like unique identifiers, and Git can't really process like generated files very well. They're like thousands upon thousands of lines, and we check in things and it's like 11,000 lines changed in this one YAML file. And so when there's a merge conflict, we essentially can't deal with it, have to just discard one set of changes. That's why there's the they don't play well together.
So kind of to bring things back to distributed systems, so does Squish, your game, have online play? And if so, is that something that you've contributed to?
No, and we talked about it at the end. We were talking with the publisher, and they had a requirement, like it needs to have online play if they're going to pick us up. And we had a long brainstorming talk with all the programmers, and concluded at that time there was no way we'd be able to implement it. At that time, I wasn't involved in the programming side, and only one other person on the team had taken distributed systems, so it was like a sort of big, scary thing. But now I have this, what is it called, a JJPO to look into?
Yes.
So I've been ramping up. That's like my weekends project, is to try to figure out how to get netcode into our game, because I would love to be working on distributed systems again, because I don't have a lot of opportunities to work directly in code distributed systems.
Yeah, GGPO. It stands for Good Game Peace Out. But it's the name of this rollback networking library that's used by a lot of games for and it's so that I'm looking at their website now, ggpo.net. So they say it's designed to hide network latency in fast-paced Twitch-style games, which require very precise inputs and frame-perfect execution. And so I'm fascinated by this topic, and I'm also fascinated by the fact that there's a whole lot of work, I think, that goes on in game dev that mainstream software developers, I think, could learn from. But that learning tends not to happen because game developers have their own distinct vocabulary for a lot of things. So these game devs are solving really hard distributed systems challenges in creative ways. But that knowledge doesn't necessarily make it to the larger software development community because either because the code isn't open source, or because game companies don't want to talk about what they do to make their game good, or even just like, even if the code is open source, just the way in which it's documented and discussed tends to use this entirely different set of vocabulary than mainstream software development does. So GTPO is actually, it's publicly available on GitHub. You can, and it's, I think, MIT licensed. So I think that means that if you want to use it in a for-profit project, then you have to contact the developer about other licensing. But yeah, it's really cool. You know, what little I know about it, it seems really cool. The idea is that if you're playing online, there's obviously this network delay. So rollback networking will try to predict what the other player will do, and it'll run your inputs locally, and it'll try to predict what the other player will do. And if that then turns out to have been wrong, then it will roll back to whatever point in the game state that it was at, and continue from there once it receives the remote inputs. But it turns out that the input prediction can be pretty good, and most of the time this can provide something that feels a lot like offline play for a lot of games. Yeah, it's really cool. Let me see what other, let's see if there's anything else being asked here. Somebody else also asked about another question for Emma. Does UCSC own part of the rights to the game?
No, we investigated this near the end of the school year, and the game design program, like the folks who are involved in the administrative side of the program, the professors, actually, it seems like have made an effort to ensure that our games are completely our own. So UCSC has no ownership of it; it's completely ours.
Cool. All right. So let me try to bring Lawrence and Pete into the conversation some more. So I want to talk about your experience, Lawrence. You mentioned you're a machine learning engineer. So somebody actually asked. So on our start of course survey, so I surveyed everybody at the beginning of this course about what questions do they have about the course, or about distributed systems or anything. And one of the questions that was asked had to do with machine learning. So somebody asked, let me bring up the actual question that they asked. So the question was, what sort of ML applications exist in distributed systems? So I have some thoughts on this, but I'm curious about like what your work is and what you do that's kind of in the intersection of machine learning and systems.
Yeah, so I'm not sure if this really would answer that question, but the kind of the work that I do is kind of, I'm try to think of like the flow so we have data scientists who just kind of like write code to make to write some sort of model, right? And a lot of times there's just a lot of just like different scripts littered across like some sort of code base, and then they pull up a Jupyter notebook and then they run it once, and it's like, I guess it works. And there's nothing short of a lot of like graduate student kind of code or whatever, just to show like, hey, here is a concept, it works. But the problem is that like, okay, we're actually making production level code, and we need to actually make this into something that's going to be usable.
Yeah. So to be clear, just so that the undergrads in the course know, when Lawrence says graduate student level code, he means bad code.
Not known for good code.
But the way that I kind of look at a lot of machine learning applications is they're just, obviously there's a lot of math when it comes to it, where there's a lot of hardcore machine learning techniques and anything. But like when it comes down to it, it's mostly just like really either data intensive or just like compute intensive applications that just like take a lot of time to crunch certain numbers. And what we notice and when we're deploying like some of these applications to any kind of cloud service, that we're not doing it in a very intelligent way, where it's just like there'll be these really compute intensive applications in like one node, and there will be like 8 people even. It's like such a low number hitting this one instance, and it will just come to a crawl. It's just like, I can't function. So we have to think about like, okay, we have to like either replicate this whole entire application. How do we do so in like a much more intelligent way? But even so, I was thinking about it, what I'm doing now. Actually, I'm leading initiative is how do you make it easier for the data scientists at our company to not only have the same kind of like low overhead of just writing code how they're used to writing code, but also being very easy to quickly spin up and deploy, and also be scalable, whether it be horizontally or vertically. And there's a framework that's used at Netflix called Metaflow that I discovered. Um, that what's really cool about it is that it provides a lot of quality of life tools when it comes to scaling horizontally and vertically, where you can think of like a machine learning pipeline where I have a series of steps. And because of the way that the framework works, you can actually say that certain steps of that pipeline could be even different compute environments entirely. And the way that we were writing code and deploying code before, that would have been almost impossible, because we would have to write every single step of the machine learning pipeline in its own little microservice and deploy that, and it'll be in that compute environment. But what we most likely do is package everything together, including like, the back end and like the front end too. And it was like this big monolithic, piece of software. And we had to kind of choose like the compute environment that was best for like the most intensive part of that pipeline, which is not ideal. Like you don't, for most of the pipeline, you don't need a GPU. But because step like X2 needs something that's really compute intensive, we have to deploy it and scale out from that point, instead of just scale out just scale up just that section of the pipeline. So I'm kind of working on not only making it easier to scale up and scale down on demand for different applications, but also still making it easy for the data science developers to actually just write their code like they do normally. Because I think a lot of times they kind of get scared off by a lot of I guess like software engineering types of writing code. It's just like a lot of people I've met at the company just don't like using Git, but they have to. So even like getting them to do something as simple as like, using Git, at least for us simple, is kind of a headache. So kind of like spoon feeding them and trying to make like the overhead so much lower to adopt new technologies so they can still do the same work is kind of really important for me as well.
Yeah, I mean, that's a great point. There's so many things about what you just said that I want to riff off of. But just that last thing that you said about Git. So this kind of relates also to Emma's earlier point about how Unity and Git don't play nicely together. Notebooks and Git don't play nicely together either. And this problem of how to properly version Jupyter notebooks, which are now the de facto standard for anybody who's doing data science, right, in industry. This problem of how to properly version them is kind of an open problem. And this is something that I personally struggled with last quarter, because I was teaching a new undergrad course we have here, CSE138, which is taught entirely using Python notebooks, hosted on Colab, which is Google's hosted environment for Jupyter notebooks. And so we're developing these notebooks, and I was working on them together with other faculty members, and we didn't have any good way of versioning them properly, right? There's like some hacks that you can do, right? Like you can use Git hooks to strip out the unnecessary stuff in the notebook, or any changes that aren't essential, like the number of times a cell has been run, that kind of thing. But this is just kind of a hack to make this thing that this thing that's meant to be interactive, right? And is kind of not intended to be used in this traditional sort of line-based version control sort of way. It's kind of a hack to make it to shoehorn it into that. So
yeah, definitely.
And
a lot
then
of times I
everything.
just find in other people's like computers is like, I don't know what notebook it was working in. Let me look into like my Finder, and then just like it's just like horrifying to see just like working version 2.0, really working version 2.0.
Right. But on the other hand, you don't want to impose a particular workflow on people who have a workflow that works for them. Yeah. So no. So I guess I mean there's the part of the challenge here is the stuff that you just mentioned about version control, but then there's all of the other stuff that you mentioned about scaling up machine learning and data science to run in a distributed fashion. And so I'm glad you brought up Metaflow, because I actually hadn't been aware of it. That's really interesting, and it's really cool that it's open source.
Yeah.
So my partner likes to, so he works at Google, and he likes to talk about how Google is a machine for turning machine learning problems into systems problems, which is like a kind of a reference to how, like, at Google, they do machine learning all day, every day, but they're doing it at a massive scale. And this is actually very relevant to what we're going to talk about on Monday, which is MapReduce. So MapReduce was kind of the first in a series of frameworks that are intended to help people solve the kind of machine learning application problems that Google has, but at a huge scale. And so there now exist open source versions of those frameworks. But it sounds as though Metaflow is addressing a slightly different problem, right? Like, it's for people who may not be systems programmers
Right.
at all, who are so.
It's kind of just like balancing that like role of like, I need to hire the best DevOps person ever, and also I need to hire the best like data scientist ever, and either they have to work really well together, or they have to be the same person, which is both impossible. And I think that you're right. You know, like a lot of machine learning problems are just boiling down to systems level problems. But at the same time, too, not every company is Google, right? And not every company has to solve Google level problems.
Right.
Even the very small companies have big problems that they deal with because it's big in their world. And for my company, at least, we don't have we make machine learning applications for like other like clients. So it will be like really big name clients that are like either in like the energy sector or the healthcare sector or whatnot. And usually their like user base is like 10. And it's really interesting. It's like, okay, well, it's like 10 people using this application. You think about like most like web apps or anything, these days, like, okay, that'll work. But like, it's not just a simple web app. It's like something that's like constantly like going to pandas and then just like, crunching all these numbers in NumPy, and then, okay, we're going to ship it off. We're going to go to this, touch this API that's going to like, some TensorFlow part of the flow, whatever. Like it like ends up just like ballooning really fast, even just for 10 people. So learning how to like kind of scale that out and actually be like, again, like another distributed systems, like, buzz term, be fault tolerant is really important.
Yeah. And I think something that's underappreciated is the vast difference between having one user and having 10 users of a system.
Yeah.
So I want to bring Pete in also. So Pete's experience is a little bit different from Lawrence and Emma in that Pete is an academic. But I think Pete's work also is in this intersection of systems and machine learning. So Pete, I wonder if you could talk a little bit about kind of how you ended up choosing to go to grad school and a little bit about what you're working on now.
Well, I chose to go to grad school because when I was an undergrad, I took classes. I took operating systems taught by Gerald Long and computer architecture taught by Heiner Litz, and they're both in this storage systems lab. And I really liked both classes. I got along really well with both professors, and I got a chance to meet with and chat with some of their grad students and learn about the systems that they're working on. And I thought that those were really interesting. And so the work that Heiner focuses in is architecture and systems and storage work focused on data center applications. For instance, what I'm working on is storage accelerators that are going to be used on networks in data centers so that you can separate the storage nodes from the compute nodes. And in some sense, you could think of it like MapReduce, but on individual hard drives. So I'm really interested in this because I think that one of the big pushes that we need to make, like sort of as a society, is to make our data centers much more efficient than they are, so we can stop boiling the oceans, or at least make it not get any worse. And that's the sort of thing that we're working on in my lab, is more efficient applications for data center providers. And so the sort of work that like, for instance, what I'm working on right now is a system to take compute, like a CPU or an FPGA, and co-locate it with the hard drive. And so one of the ways that when we're talking about it with people, is we talk about MapReduce, where when you're talking about a sort of MapReduce system, you would have many servers with discrete storage that they can utilize over a very large network. And we're talking about doing that within one server instead. So a much like lower level problem. Hopefully, I don't know if your class has read the MapReduce paper yet.
We're actually reading it for Monday. So
hopefully some of them have.
Yeah. So yeah, we're going to be talking about it starting on Monday. Yeah, that's so I don't necessarily want to assume too much knowledge of MapReduce right now. But yeah, we'll be talking about MapReduce. So like I guess a one sentence description. So MapReduce is a framework that will allow you to plug in pieces of code that will then be automatically be distributed and run in a fault-tolerant fashion on many machines in a data center, for the goal of accomplishing a variety of tasks that Google was interested in accomplishing in the mid-2000s. This is and MapReduce has been succeeded by. So if you're familiar with Hadoop or Spark, those are the open source equivalents of. So Hadoop is like an open source equivalent of MapReduce, and Spark is its successor in some sense. But we'll talk about all this on Monday. I want to bring in a few more questions that folks are asking. So a couple of questions for Lawrence. So one person asked, what are the distributed systems technologies that you use? And also for machine learning, do you lean on machine learning libraries, or do you tend to implement things from scratch?
As far as like the machine learning technology that we use, something AWS. I mean, as far as like a distributed systems technologies, we use something AWS, right? Where just I think one of the biggest distributed system, I don't even know if this will be in the same category, but one thing we're leaning on specifically for distributing large compute loads is an AWS service amongst millions of AWS services called AWS Batch, which allows you to quickly spin up in this isolated compute environment for whatever you want to throw at it, whatever kind of numbers you want to crunch. But with some of the applications that we're writing, we want to think of this one script of code, right? We want to actually split up all this entire script into 5 different containers, So how would you do that? So leveraging different frameworks to help you containerize pieces of code and then send them to a batch instance, and having each of those containers be like different, like, either amount of memory or how many, or one of those containers have a GPU, one of them has like 2 CPUs, and then all joining together, maybe in like a MapReduce type way, where like, here is the final number, here is a CSV that you can show your boss, and they'll be like, that's nice. And then can you repeat the second question one more time?
So for machine learning, are you relying on existing ML libraries?
Yeah, I think that everyone wants to still stick with, like scikit-learn and like, pandas and everything. You don't want for a lot of like the applications we write, we still use a lot of those off-the-shelf machine learning libraries and frameworks. We do actually have in-house machine learning libraries that we use, and machine learning like microservice that we just do like API calls to get some sort of reasoning back. But so for the most part, everything that you can like Google and learn yourself, like we're still using that today. So like any of those things that if you take in a machine learning class or taking a AI class and they say like, here's some like Python libraries that you use, we still use that today, but we just really like mutate it into get exactly what the results we were looking for. So yeah, so a lot of it, so some in-house, mostly like the standard libraries that you could find in PipaSolve pretty much anywhere for Python.
Yeah. So in the CSE138 course that I taught last quarter, we touched on machine learning a little bit, which was an exciting thing to do for an intro course. And so what we did was, so an aspect of any, well, not any, but many machine learning frameworks is automatic differentiation. So what we did was we had started by implementing in Python just kind of a representation for arithmetic expressions, and then once we had that, it was like, oh look, you can implement something that mechanically takes the derivative of these arithmetic expressions, and then once we had that, we realized we had most of the pieces for implementing a toy machine learning framework that did automatic differentiation, although very slowly, and not the sort of thing that you would actually use in production. But once we had the auto differentiation, then all you had to do was kind of wrap that in gradient descent, and then you had this kind of slow bad ML framework. So it was a fun thing to do. But I also, and I'm glad that we had the chance to do it. But also, I want students to understand that if you're doing this in practice, then you would never implement that stuff yourself.
You don't have to build everything from scratch.
Yeah,
you just have to, a lot of like software development is being like, it's like playing with Legos, right? Where it's like you don't have to make the Legos, or you don't have to mold the actual Lego itself in order to build like, a spaceship or whatever. Like you buy the Lego pieces and put them together in really interesting and unique ways.
Right.
I mean, maybe that's a very crude way of looking at software development, and it's definitely, there's a lot more depth there than that. But
no, I think that's a good analogy. I mean, I think so. I like that analogy because it makes clear that there's still a great deal of creativity, right? Just like there's creativity in building things out of Legos. Even if you're putting together pre-assembled pieces, you can do it in infinite ways, right?
Right. And like things like what Pete's doing is like more of that, I'm molding the Lego itself, so you can get really deep in that. And so it really depends on like, what side of like, what side of the stack you're at, are you going super low level where just like, what is a Lego?
Right. Yeah. So speaking of these low level architecture questions, another question, a question for Pete. Pete, do you work with RISC-V, and do you think that RISC-V is useful in industry?
I think RISC-V is certainly useful. It's used in a lot of not PC applications, but like a lot of phones and embedded systems and things that don't have keyboards use RISC-V because those chips are designed for efficiency in a lot of ways. I don't work with it. There's some chance that I might, but what I work with is C and C libraries in an operating system level, so inside the kernel, and using some sort of standard libraries for developing storage systems. And there, I'm on my project is someone else who writes a language called Verilog RTL, which is used for programming FPGAs. And then we have somebody else who's really good at Python. And what our specific project is trying to map this sort of not data scientists, but we work with the UCSC Genomics Institute, and so there's a specific application which is written by these bioinformatics engineers in order to do genome mapping, and we're taking this application and trying to make it run really fast on specialized hardware. And so it's this code which kind of the same problem that Lawrence is dealing with, where you have these people who software engineering is not their main focus. And so the software that they engineer is maybe not as elegant or well written as what you might hope. And we're taking that this code that was written in some higher level language and trying to translate it down into something so that we have pieces that'll run on distributed architectures.
So another question for Emma, is, again, to do with funding for the game. Has the team considered getting VC funding?
Not really, I guess. I'm kind of the only person on my team who is doing, pretty much everyone who's remaining on the team is just a developer. We have 2 artists and one of our programmers is leaving, so we're down to 4. We have 2 artists and 2 programmers, and I am kind of filling the gap of everything else. So I work with freelancers and I work with publishers, and I kind of full up on work.
Sure, yeah.
No,
yeah, looking for funding is itself a full-time job.
Yeah.
As I know, as a professor.
If you'd like to give us money, like if there's anyone in this class who would like to give us money to work on this game, then we would love your money.
Is there a free-to-play demo?
There's not right now.
Okay.
We are going to be participating in the game showcase at UCSC since it's fully online this year. So you will be able to play Squish during the Sammy showcase, which is going to be during finals week. So I think the 2nd week of June.
Oh, nice. Okay. All right. I will advertise that.
Thanks.
Cool. All right. So I want to turn to a different topic. So so all of you graduated last year and are working either for yourselves or for someone else. And so a lot of my students are graduating into what is now a not very promising looking economy. And I'm wondering, like, what kind of advice do all of you have with the hindsight of being a year out from graduation, for somebody who's about to graduate with a computer science degree, especially in the age of COVID-19? What kind of advice do you have for them on job searching and life after graduation?
I mean, again, a very heavy topic.
Yeah, not to be a downer here, but
yeah. Honestly, I think my bit of advice is just try to, in some sense, try to, proceed as normal, where you're still applying for jobs, like don't not apply for jobs, don't not like polish your resume and polish your LinkedIn and all those things that you have to do in order for a recruiter to say that wow, you know how to use a computer. That's super important. Other than that, though, do everything you can to like kind of like looking for a job in even a normal world is the most like some of the most stressful things you could do. And so I can't even imagine doing the same thing where like you don't already like have like a job or have, secure, money to like, keep you afloat. It can add another layer of stress. So whatever you can do, just try to stay mentally sane, take breaks. You don't have to like constantly be grinding. Like be grinding, but don't grind to like yourself to like to the bone where you're just like not even a person anymore. So like yeah, so I would say yeah, do some leak codes, but don't like do 400 leak codes in like a week because like that's just going to like ruin your like mental health. But still, just kind of look at like jobs and just kind of apply. And I think sometimes a lot of people reach out to me and ask like what they should look for, and a lot of times I just say like think about like the applications you already use and just apply for those companies. And that's kind of like what I did when I transferred to Santa Cruz. Like I was just like, wow, I'm here now, and now it's like actually really serious. Because like when I did a lot of work to even get to a point where I could transfer from community college to like a university, and being surrounded by a lot of people who are like at this like really like nice university, and just like man, like I gotta like step up my game and really think about like also what I'm gonna do because I'm not gonna be here for very long. And so I started thinking about like things like, I'm not even working in this field, but started thinking about like streaming platforms like Netflix and like Hulu and stuff like that. It's like I don't know how those work. I should learn how those work and try to get into that maybe. And that's kind of like what led me down the path to actually join distributed systems. And like because I was like I asked like a bunch of teachers. I think I asked in like my 101 course. I asked like, hey, I'm interested in like Netflix and how that works. How do I learn about that? And he's like, I don't know. Like maybe talk to this professor and talk to like I think he like referred to like maybe like talk to like Daryl at first. I didn't know Daryl at the time. I was taking OS, and then eventually just led down like seeing Peter's name and just like he's like, oh, maybe that will be the right class for that, and then the rest is history.
Yeah.
But
well,
anyways,
Peter's absolutely the right person to talk to, and Peter's actually worked directly with people at Netflix on their chaos engineering stuff. So yeah, I'm glad that you discovered Peter's class.
Yeah, and I think it really comes down to like I watch Netflix, so might as well, and obviously it's software, so maybe apply for it. It's something as simple as that, and then also just like obviously looking at like any kind of job hunting website and just like maybe that sounds cool, and then apply for that, even if you feel like you're not, qualified for it. I think a lot of people worry about that. It's just like I don't have 8 years of experience, and sometimes it's just like it's a mistake on the application. Like it says junior role and it says 5 years of experience. So it's like that doesn't mean anything.
Right. Or like
anyway.
in 2005 when I was just out when Ruby on Rails was new and people were asking for 8 years of Ruby on Rails experience.
Amazing.
Yeah, I mean the people who write these things are not necessarily the people who know what's up.
Right.
And it's funny that you mentioned leak code, which I think so I think it's important to keep in mind that interviewing for a software engineering job is a distinct skill that's different from what you learn in school, which is, that's sad but true, right? What you learn in a computer science or computer engineering undergrad degree is, while important and useful, is somewhat distinct from what you have to be good at in order to do well in the interview. And and so, I mean, at Stanford, they even have a course that's called Problem Solving for CS Technical Interviews. Like they actually go to the trouble of having a course that's specifically devoted to doing well in interviews. It's like a 1-credit course, right? But just the fact that they do this makes obvious that interviewing is a specific skill that you specifically need to learn. And so, you know, as an academic, you know, I guess, you know, back when I wasn't an academic, so I worked in industry for about 4 years between undergrad and grad school, and then I worked in an industry research lab for a while before coming here. But I certainly found it to be the case that interviewing, I was not good at technical interviews because I don't think that the interview context did a particularly good job of showcasing what I'm good at, and I think that a lot of people find this, and they find that they just have to specifically study interviewing skills in order to do well in interviews, and it's unfortunately the case that that's not covered in the standard curriculum.
Yeah, totally. I mean, there's many Medium blogs about how the interview process is broken.
Right.
And I definitely have some thoughts about like the Stanford course and everything, but I won't really get too much into it.
Yeah.
But like, yeah, I think that even it's another layer to it too. It's like the academia is the way you learn academia doesn't really directly translate to leak code. Like you could take some one-on-one courses in Santa Cruz, kind of get closer to that in 102 course as well, but it's not quite the same. And also, too, another layer to that, you have a job and you want to look for another job. What you did at your job does not translate to like the technical interview either. It's just like this is this weird island, and this island is the only way you can get like money, and it's really, really bizarre. And I don't really have a solution to like how it can be changed. If I did, then like I probably wouldn't I'll probably be like a recruiter or doing like, you know, talks or whatever about it. But you know, do leak codes, study them, you know, brush up on your like one-on-one and data structures and everything else like that. But again, I can't emphasize enough, like take care of your own mental health while doing that, because doing that in the normal circumstances is draining, and it can only be more draining right now, I would imagine.
I would say, in addition to that, I think we're starting to see a lot of tech companies realize that they can work perfectly fine without having everybody go into the office in San Francisco. And we're starting to see companies realize, like, we're paying a lot of rent for that office space and it's empty, and we're at 80% productivity or something. So why are we paying any rent at all? And so like one piece of advice I would give is I've seen a lot of job offers that are 100% remote just from the get-go, and it's probably worth you know, you guys have been doing this whole quarter online and remote, and it's really sucked, but like if you can take any sort of workflow that you've managed to make work for you, and take that into your interview process, and take that into the kind of candidate you're going to be, you can go live somewhere that is a lot cheaper than Santa Cruz or the Bay or LA or something like that, right? And if you're remote, you can still get one of these jobs, and they're definitely still out there.
Emma, is your
the other thing I would say
go ahead, Pete. Yeah.
So the other thing I would say is it's a really good time to go into grad school right now.
A good time to go into grad school.
Yeah,
there's something
right now is a really
that.
terrible time to be graduating from grad school, but it's a really good time to be starting grad school if you're thinking about it.
Emma, was your team for Squish remote even pre-COVID?
Yes. So most of the team couldn't afford to stay in Santa Cruz after graduating, so we became fully remote in the middle of June, and it has been a boon for us. With like the quarantine started, and our team, like work-wise, barely noticed. Mental health-wise, we did notice. But it's working remotely. It's its own skill. There's like all this stuff that you learn without even really realizing you're learning it, of working in person with other people. And there's a whole separate set of skills that you have to learn to be able to work well remotely. And on like the folks on my team have been learning that for the last, year.
Mm-hmm.
If I the leak code thing is kind of, I don't personally think those things are super valuable.
They're not.
Yeah. One of the reasons why our team kept working after the end of the school year was because we were all looking for jobs. Like we were looking quite frantically for jobs, like starting in April. We're all still, those of us who are still on the team are still frantically looking for jobs. But like, there's only like, if you're not doing the work you intend to do, you'll lose it, So one of the things for games especially is until you have a couple of years of experience, you're basically useless. So that's kind of what industry will tell you. When we went to E3, that was the thing we were told over and over. Like, just keep working on the game because no one's going to hire you until you have a year of experience. How do you get a year of experience? So that's why we kept working, so that we could keep practicing. And we had two people on our team who got hired to another company because they saw us at E3, they saw our game, and they took our lead developer and our lead designer because that's what they were looking for. They just kind of stripped from our team to work on their game, which is somewhat similar.
That's kind of bittersweet for you, though, right? I mean, it's a big win for them, but now you've lost those people.
Yeah, but it meant that the people on our team who knew our code base pretty well, but were sort of, I guess, in the shadow of those two people who they're really great people, they have been able to step up. So like we lost our lead designer, but one of our other designers has sort of stepped into the role and has gotten, because we've spent a year working on this project, has gotten a lot of good skills that they can apply to another job. I myself have started getting like reached out to by recruiters, like through LinkedIn, of like, hey, it looks like you have a lot of game development experience, because I have listed that I've been working for a year and a half at Grave Rave Games. And I have been, like, we've been working full time for the last year. So some of it's just time, just like keep doing stuff and be open to stuff that'll happen, like maintain your LinkedIn and keep interacting with people who are in the industry that you're interested in working on. And someone will just say, hey, we need this thing, and I know this guy, let's interview them. The programmer that is their last day is at the end of next week. That's exactly what happened. They're getting hired onto the same team that took our lead developer and lead designer because they know him and they love working with him. So as soon as there was enough money for that company to hire another person, this was the first person they reached out to, one of the developers on my team. So that's how he was able to get the job.
Yeah, you can't underestimate the importance of those kinds of connections. There was somebody, so some of the students in 138 here I've been talking to some students who are struggling in their job search. Maybe they even had an offer and then the offer was rescinded because of COVID-19. And so I've been kind of talking to people and in some cases helping them connect with potential employers. And so I spoke to one person who had done an internship working with this particular niche technology. And I talked with a friend of mine who it turns out that her team actually uses that same technology. And I was able to connect them with each other. And it's and interestingly, this student in the class had actually applied to work at this same company before and not heard back. But then after I made the connection, and I didn't do anything other than saying, hey, here's this person that I would like to bring to your attention. And then the student got an interview. So it's like it or not, there's a whole lot depends on those kinds of personal connections. and it's that's the reality of it. And so it doesn't, and I mean, I would encourage, so for example, I use Twitter a lot, and I use it, you know, I don't feel as though I'm setting out to do professional networking when I use Twitter. Like, that's not why I'm there. But it ends up being professional networking. So I think, like you know, you should approach these things not with the attitude necessarily of, I'm going to use this to make professional contacts and grow my professional network. You should approach it with the attitude of, I'm going to use this to learn and have fun, and then or approach social media with that attitude, and then in the process of learning and having fun, you will meet people who sooner or later will be incredibly valuable for you to know in your career.
Yeah, Twitter's great and also terrible. Like I joined Twitter in a while ago, but I didn't really start using it until like maybe like a year or two ago, and mostly now. And tech and academia Twitter is like my saving grace, you know, because I moved back to LA because my home, and I also love like LA people, which are very just like entertainment type people, and just because it's just great people watching. But I also still wanted to be connected to like, you know, that tech world and everything, and just like in like the deep computer science world. So the best thing I do is like, okay, I'll follow my professor on Twitter because I'm a nerd, and I'll follow like, you know, other people that are doing cool stuff that they're following, and then it just like, you know, goes from there. And I'm just like watching people kind of deal with their daily lives, you know, even outside of like, you know, what their job is or what they're researching too, and then also, you know, bring it in. And then they'll often say, when I see often like post or tweet, hey, we're looking for like, you know, engineers now, you know, and then like you could just like DM them, and then they'll realize that you're following these people, or people are following you, and there's like commonality there. So what ended up for me, you know, like, because I'm not like really super active looking for like another job or anything, but like what I noticed is this community I was kind of looking for and everything, I kind of found while I like, you know, kind of watch TV or whatever. And then like if I wanted to reach out to anyone, because everyone, it's so like casual and not like, you don't have to put on like a suit on Twitter. You know, it's very discouraged to put on a suit, but everyone knows that you're a professional and everything. And it's also a great place to share things too. So if you have like a side project or something, you know, like, hey, post on Twitter and maybe like, I don't know, like maybe tag someone. I don't know. It kind of seems like, you know, you're giving out CDs at like a show and everything when you're like tagging randos about like something cool. But like, you know, just like sharing like what you're doing there, and then other people that you're following or following them are like, hey, that's cool too. And then the people that following them see it, and then it goes from there. But yeah,
honestly, I just use Twitter to make jokes, and
yeah,
then
same.
you know, people like the jokes, and then they follow me, and then we end up talking about distributed systems. So
I use it to just complain about Docker.
Yeah, that's one of my main use cases for Twitter as well.
And then other developers who are like working at Google or something, like, I also hate Docker. Come work with me. And that's kind of how it works sometimes.
Yeah. Yeah, a while ago, a professor on Twitter was asking a bunch of professors, how much time do you spend in a given, like a bunch of CS professors, how much time do you spend in a given week writing code? And my question in response was, like, are you including time spent waiting for Docker or not? Because that matters.
Right.
And yeah, so I mean, there's a whole lot of like haha only serious interaction on Twitter where like you're joking but not. But yeah, I mean, I don't want to, like, Twitter in many ways is a trash fire, so I don't want to say that Twitter is like this unqualified good. But it's been I think Twitter has, on the whole, on balance, been like good for my career.
Honestly, just finding a like whatever community you're part of, you know, kind of just reaching out to that community is probably like what I would encourage. So if you're like part of some sort of Discord channel about some niche or whatever, let's say it would be like Animal Crossing, because that's just like on my mind right now. There are people who are playing Animal Crossing who also are software engineers, or they're project managers, or maybe they're recruiters or anything. And then you can just say, hey, I'm looking for a job, come to my island and I will do an interview with you, and then go from there. And I think that like could be a starting point. You don't have to like do only the traditional route. You could also reach out to people who are like, you're in class with, right? You're like ex-classmates or current classmates or whatever, or even just like alum that you find on LinkedIn who graduated a couple of years ago. You can always reach out to me and I'll do my best to like help you out as well. But like, the worst thing you do is just stay silent. And then like, but if you like just say like, hey, I graduated, this is my skills. The worst I can say is like, okay, I don't know if we're hiring now, but I'll always do this. I'll just DM the recruiter on Slack, are we hiring now? And then he'll say no or yes. And then I'll just say, okay, cool, here's this person's name, regardless if he says no or yes. And then hopefully it sticks to his head.
Yeah, that's great. So I guess on that note, we're out of time now, so we should wrap up. But Lawrence, thanks for the generous offer of offering to connect students with people. So I would love to be able to ask our students to reach out to any of you if you have questions about whether it be grad school or game engineering or looking for a job, because I feel like there's a great deal of knowledge and experience, even in people who are just 1 year out from graduation, that they could turn to you all for.
Yeah, I would say also too, just
please.
a final thing. Well, thank you for having us too. Is that like I've kept on learning a lot more after school, and I think that you should expect that. Is that like, oh, you got your degree? That's great. Continue doing that thing that you got your degree for. And you're just like, you find this like craving of like, I'm reading like this book, Designing Data Intensive Applications. It's like a fascinating book.
Oh, it's such a good book, actually. The image on the front page of our course website is actually taken from the book.
That's awesome. Yeah, I mean, like, so never stop learning, I guess, is as cliche as it sounds, but like, you're going to have to never stop learning because it's how you survive in like this industry, because everything's evolving so quickly.
I would rephrase it and I would say like a lot of what my experience in undergrad taught me is just how to learn the new skills that are really important and that I actually use.
Yeah,
because I'm learning new libraries and new languages and new systems all the time now.
Yeah. Well, we are unfortunately several minutes over time now. I would love to continue this conversation. It went by really fast. But I want to say thanks so much to all three of you, Emma, Lawrence, and Pete, for being willing to talk with my students and me today. And I'm going to share all of your contact information with the students, if that's okay with you. Thanks again for being willing to do this. It was lots of fun.
Thanks for having us.
Yeah, thanks for having us.
Thank you.
Sure thing. Yeah. All right. So we're going to wrap up. If you're in my class, read the MapReduce paper for Monday, and have a wonderful weekend. Take care, everyone.